We're up and live. It's about 6:44. We'll wait a few minutes to grab a few people, see how it goes. Wake up, category theory universe. Hey kids. We have one viewer here. The conversation's ever so much better if our one viewer actually joins in the conversation. Hello, hello. Welcome home, Rama.
Hey, how are you guys doing? Hello?
Working hard or hardly working?
Yeah, very hard. Thank you.
So I take it you saw Mike's notice about the fall?
Yeah, I'm very excited. I not had any course in algebraic geometry. Sorry, algebraic numbers for a long time. I mean, not never took a course in algebraic numbers. I'm looking forward to that. You're going to be there, right?
Yeah.
I'll be there for
Possible.
the first term, that's for sure. Second term depends on how I'm going to get my project and all that. If I continue at Northrop, I'll be home. I'll be in LA, so I can continue.
Yeah.
But definitely there for the first term.
That's good. Well, we'll send you the notes for the second term if we need to.
Yeah, look forward for that.
And for
So I
Daniel,
missed a couple of sessions. Where are you guys now?
um, so last week I was out and I, turned the camera on, so I don't know who caught it and who didn't, or if anybody showed up. Um,
Okay.
but we had finished chapter 4 essentially, either skimming or glossing over the last section, which was some applied stuff.
Okay.
And I've kind of since gone through even most of that, and you know, it's interesting, but it's easily skippable, I think. And then
Okay.
we're, last week technically would have been section 5.1, and this week would be section 5.2. Although I've yet to, I don't think I've updated the syllabus to actually match that fact. Um,
Okay. Because if you guys are already heading finished session 5.1, I'm still on 5.1.
but I don't
So
think anybody really discussed 5.1, so we can chat
okay.
about 5.1 and 5.2 here this week, and then next week we'll do. I have to look at how much material it covers because I've just started reading it, part of it today
O-
myself.
Which
Okay.
one?
If you can throw that book online, we can just go through some questions I have and probably go through each of sections. And I have some questions. I'm sure others have questions. We can sort of see if we can resolve some of them.
Yeah, let me see what I
Can you guys hear me or no?
Yes.
is that a run? Yeah, we can hear
Yeah,
you,
this I don't know. Okay, cool. All right.
or we can hear you now, at least anyway.
Okay.
Yeah, if you give me a second, I should be able to throw this up and put it on, or share my screen, possibly. Um, I did spend, or while I'm trying to pull this up, I did spend a few minutes at the tail end of last week looking at, I think it's MJ Codrington's YouTube channel, stuff on category theory. He put together like an hour's worth of material in 6 chunks that he calls lesson one, and he's doing the category theory with a dose of music theory
Oh,
and
nice.
some programming, although he hasn't gotten
Uh-huh.
into the programming or music theory heavily yet. So it's mostly kind of basic
Why don't you
intro.
post the link to us? We can take a look at that.
But for an hour's worth of videos, it was actually some pretty interesting stuff with some interesting applied music related stuff. So I kind of want to join into that.
Hmm.
But I don't know when he's going to post up his next segment. But a lot of the stuff he covers in his first lesson is somewhat similar to parts of the first 4 chapters we've done so far in this book. But it's
Okay.
also, markedly different in some respects as well.
Okay.
But I would say it's an interesting thing, and I'm hoping now that we've actually started chapter 5 that I want to dig into the Eugenia Chang's got, and one of her colleagues did a series of category theory videos, the Catsters, I think. I don't know if anybody's
Yeah.
looked at that.
I looked at it in the past. They're pretty nice, but they're at high level.
Yeah, I was going to say it looks like they're starting off in chapter 5 and moving quickly from there. So
Yeah, most of the I actually glanced through some other category books that are like supposedly extremely introductory level, and they pretty much start off with like the first section is chapter 5 here.
yeah,
And the more I think about it, the more I realize that's probably I mean, this is for people who haven't had background in abstract algebra and things like that, right? So you need 4 chapters to get through all this kind of stuff, I feel.
yeah.
Yeah.
In fact, I've kind of been waiting to like even delve into some of the other category theory books, knowing that they're roughly starting at about where we're at in chapter 5. So
So I see that you got chapter 5 on screen.
yeah, I was going to say, let me see if I can pull it up so that we can actually see it.
At least for me, it looks very small.
How can we blow this up? Some of this stuff. That better? Where do you want to start, Rama?
Yeah, that's a good font. Just can you skip through, just page down each page as you go through. I had a lot of questions as you go forward. Okay, go to next page. Yeah, go to next page.
Step up.
Nothing here. Keep going. Yeah, the definition is, I think there's no issue here, right? Category 2 definition.
Yeah.
Yeah. And he's got a constituents is the case. He calls them A, B, C, D, and he's got two laws, 1 and 2. Okay, go ahead. Yeah, next page. You can skip this page, I guess. Small category is interesting. Never understood what it is. Now I understand what a small category is.
Yeah.
Yeah, that's it.
Yeah, sex is fine. Then example 5114, that is also fine. Then finites is also fine. Go ahead. Monoids is fine. Keep going. Next page. And then of course remark 5116 is there with.
Oh, this is the one that I had a question about why it's both called you. There's another question.
Yeah, I don't think he's specific. I understand. I guess what your question is, I don't think he's calling it you. He needs the you out there because the homomorphism needs to.
Yeah, I was thinking that it's actually another injection, right? So it should be called some V or some other.
Yeah. But I guess he wants to stress the fact that U has to be the one that's porting this A and B into like home of C, UA of UB. I guess that's what he's doing. That's all.
Yeah, I had briefly mentioned. Oh, sorry.
Yeah, that's correct. There's no it could be called anything else. But I suspect he's giving a label U because he wants you to understand U is the one that's when you do home of AB, it has to be home UA, comma UB.
Right, and I had actually posted on the question like an hour ago about this.
Okay.
So this basically mimics a functor, right?
Okay.
So this is essentially a functor if Q is a category, right? So that's kind of why he does it, but I feel like maybe he should have like mentioned that U and these are different functions, or just using this notation.
Yeah, I guess there's no.
Yeah, exactly. I think so. Yeah, that's what I was.
Yeah.
Right. Yeah, so it is technically two different functions, but you just or maps or whatever things.
Two different, yeah.
But you just call them the same because there's no ambiguity. Because we know that one takes objects to objects and one takes morphisms to morphisms. So we just call them the same thing.
Yeah.
I think I gave an example. If you take in a group theory and representation theory, there's only one function for both morphisms, where there is a homomorphism as well as a direct function basically, right? So that's also can be sort of thought that way. You have some background representation theory, right?
Yeah.
Yeah, so in representation theory, you got a row that takes a element G to a matrix and G1 to a matrix, G2 to a matrix. Morphism between the G1, G2, which actually use on the element G3, becomes a homomorphism across. Homomorphisms get mapped, but they use the same row. I guess that's my understanding is that's how this is using it here. They don't use a separate name for that. Only difference here is that he's got his homomorphism mapping. And that's the injection. We need injection as that's critical for further derivations.
Yeah, I got the logic. I mean, that's fine. I mean, I got the reason why he's doing that. But
yeah. But I guess you can also label it differently. It doesn't. You're right. But it is true. I think it looks like it's a functor.
Yeah. The one thing I guess a functor might not have is the injectivity.
Right. Does it have injectivity, functor?
I don't think so.
I don't think so. I think injectivity is needed here for the derivations, but not for functor.
Yeah, you don't need the function to be injected. Yeah, functors need not be injected.
Right. So it's almost correct.
Yeah, almost.
It's always the
Okay.
details.
Any more questions here?
Well,
No.
I do have one. Hold on.
Chris, you're not coming very clearly to me.
Let me see if I can turn my speaker off. Is that better?
Yeah.
Okay. The question you guys just brought up actually makes me, in thinking about not in a categorical sense, we have to come up with a different word for it, but in group theory, for the last 4 decades or so, everybody spent a lot of time kind of categorizing and breaking out groups and essentially writing a catalog of all the groups that exists, how big they are, how small they are,
Right. Classification.
E6, E7, E8, and so on. And I know there's 40 some odd different categories that have been, at least in stuff I've read, that have been explored. And I have to imagine many of them are similar to others in terms of form and structure. But has anybody actually kind of gone out and kind of cataloged all of the various categories in terms of the shapes and sizes and functions that they have into the smallest sets possible?
I don't know. No, I'm not looking into that, but I don't know. Maybe somebody did.
I just haven't seen anything, but it seems to me, based on the explanation we just walked through for this, that certain things are equivalent or kind of the same, or categories sit inside of other categories or subsets in some sense. That there has to be some kind of root level work going on where you can map one thing into another, and they're one to one onto, and essentially equivalent from one sense to another. And I'm kind of curious if anybody's gone out and cataloged all of them yet, or if that's even a worthwhile exercise. And we may just be I'm sure way too early to answer that question, but
No
I
idea.
don't know.
it says that there's something going on there, and then the question is, what is it? I don't know. Something to think about, I guess, and we can chug along here.
Okay, if we can skip the next page. Go to the next page. I have some questions on that.
Tell me when to stop.
Yeah, this is fine. Go next page. I think okay, just stop here. This example 5119, I followed the initial part of it, no problem. I guess you need to go to next page again. I'm assuming other people don't have any questions here, so I'm just so go to next page. I have some question on that. Yeah. Then yeah, just stop
Next
there.
example,
It says
510.
that 20. Yeah, no, stop. That's fine.
Right here.
In the middle of the page, right? It says that 27 pairs of home sets. Did somebody make a count of it? Yeah. I don't know how it's coming to with 27. Is it a 3 cube?
So I guess what do we have? 3 elements, A, B, and C, and I guess
Right.
3 cubed. I mean, so you have all the different possible combinations of 3 elements. I think that's what's going on there.
But if you look at the graph, it says everything, maybe if you look at the graph, it says everything is captured here.
Right, and so I think this comes in with the where it says computation is sparse, because most of them are empty sets. So most of these 81 cases and the 27 cases are just empty sets, so they're not drawn. And there's only a few of them that actually are, and those are the errors, I'm guessing. Those are the morphisms.
So, for example, if you take A as a pair, A as a starting, he's counting not only morphism A to A, A to B, A to C, which is 3, but what is his counting? Is he counting
there's B to A, C to A.
compositions? Oh, B to A. Okay, that's how. Is it 9 he shows are the. No, not 9 here. B to A, C to A makes 8, and there's okay, we need one. Okay. So, no, sorry. B, 5. We got 5 of them. I guess he's also counting some.
No, so he's looking at the associative law also. So that's why I think he's talking about 81 cases where if AB is there, BC is there, and whether AC is there or not, those kind of things also.
You're talking compositions basically.
Yeah, yeah.
Okay, let me see if I'll write something and see if we enumerate all of them. I was pretty this is where my confusion started. Okay, thanks. At least now looks like is in. Let me enumerate a few of them and see if we can hear it. Okay, if I go to, I guess that's the question I have. If nobody else has a question, I would like to go to the second page, next page.
Well, I was going to say this example kind of reminds me of, and I think in Codrington's YouTube series, lesson 1, section 5, I think, he draws the same. Instead of drawing it this way, he draws it as a triangle with a and he kind of works through an example similar to this, but not with the kind of higher level language that's being used here. But he has some kind of nice layout about, he does some nice talking about looking at the forest and not necessarily the trees, but he uses almost the same example, I think. In this example is kind of a higher level version.
If you share the link, I'll take a look at that. I think what I'm thinking is, as a point out here, maybe there's some compositions we need to take to get the extra ones.
Yeah, but he does. I'm trying to think of how to really describe it. I don't necessarily really have the vocabulary yet. But there's a few kind of broad general laws that he talks about that we haven't gotten to yet that we probably will get to before we're at the end of chapter 5.
Okay.
That talk about some of the basics of what's going on, but he does it without all the heavy notation that is being used in this example, I think. I'll pull up the link to it and send it to you in just a second.
I didn't have any problem on that. The slogan is easy, go down. That's okay. I guess you can go to the next page. Yeah, I think I had a lot of issue with 5.1.1.14.
14?
The first problem A says, what's the cardinality of form of 0 to 3? That came pretty nicely, no problem with that. 3 to 0, no issue. 2 to 3, I start getting issues from there onwards. So did anybody try to enumerate this, or can you go explain what's happening here? First of all, homomorphism here, I mean, home here, is it just a linear order means, is it enough that two elements are just related to each other?
It's kind of, I think here it's functions that preserve order, right? So there are only 4 of them in the first one because you can have 0 is less than equal to 0, less than equal to 1, 3, and 2 and 3. So there's only 4 of those possible.
Okay.
And for
second one?
The second one we have let's see.
0 to 0, 1.
Yeah. Well, I don't think. Let me think.
Well, you see the pattern that's going on here, right? So each one of these, as he writes them from right to left, starts at 0, and then every number to the right is always increasing and not decreasing.
Yeah, I think basically what should happen is that the morphisms should preserve the non-decreasing nature. So
I'm trying to think of a good way to do this combinatorically.
Yeah, it's exactly that's.
Or how to describe it in a combinatoric. And to me, I think that's the tough part of looking at part A and part B. Is they're kind of simple enough that you can kind of look at it and come up with, okay, this is the answer. But coming up with the combinatoric formula for why that's the answer for each of those cases becomes harder. And then in the case of 2, 3, he's got it written out here, which makes it easy to see.
Right.
But
so the thing I think the way to think about it is that so there is some if you look at there's a morphism from so there's mapping from 0 to 1 and 1 to 2.
Okay.
In the category 2, right? In the linear order 2, and then when you map them to 3, the same the composition should work. That's how you can think about it. I think the composition should work.
Okay. Let me try that. That's what I thought, because what I done is
should work, and this is the only way the composition will work, because there is no mapping from 2 to 1 going backwards in the final linear order 3, right? So it has to always go, either you go from 3 to 3 itself, which is the identity morphism, or you go from 0 to 1, or 1 to 2, or 2 to 3. That's the only way you can go. So that's why it has to be non-decreasing. The composition has to work.
So the way to get listing of it is simply list for 0, what are the morphisms like 0, 1, 0, 2, 0, 3. 0, 0, 0, 1, 0, 2, 0, 3. Right?
Where you can take 0 and 1 and 2 on the linear order 3, so that the composition, the way it was in the linear order 2, how that they will also work in 3. I think that is how you have to think about that.
Okay, let me state, if
so take one of these, for example.
Yeah, square bracket 2 has elements 0, 1, 2, correct? And square bracket 3 has set of elements of 0, 1, 2, 3.
Right.
So if I take 0 from the first set, I can match 0. That's a legitimate element for this form of this form here, form of F here, right? And 0 can then, depending on the, if it's ascending, then we can say, okay, 0 can get mapped to 1, you can map it to, and the relation between 0 and 1, and 0 and 2, and 0 and 2.
If 0 gets mapped to 1, then 1 and 2 cannot get mapped to 0, because then the composition won't work. So 1 and 2 can get only mapped to either 1 or 2 or 3. 1 can only get mapped to 1 or 2 or 3, depending on where you map 1.
Exactly.
2 can
exactly. One can get mapped to either 1 or 2 or 3, and 2 can get mapped to 2 or 3, and that's where it stops. Okay.
Yeah.
So it doesn't still, when you map and count that way, it doesn't exhaust all 20 possibilities. So what happened to remaining things?
No, the possibilities are actually, if you actually do like we did for the other question, there are much more possibilities.
Okay, you want me to take compositions, then count them basically.
Right, that's what he's doing there. He is taking the ones which are valid compositions. I mean, if you want invalid, you can do other ways also.
Okay, let me try it out and.
For example, 102 is a composition that you can do. I mean, basically, you map 0 to 1, and 1 to 0, so you're going backwards, and then take 2 and map it to something else. But that won't work because the morphisms won't compose.
Yeah, no, those morphisms won't compose, obviously. See, what
Right.
we
So
can,
that's
what,
why
what,
if you eliminate those, these are the other ones that are left.
then you say, okay, then you say you get 20. Okay, let me work out and see if I get 20 or not. I'll send you guys a posting on that one later on, okay? I understand what you're saying, and I think that's what I was suspecting. Maybe I need to see composition, but directly I couldn't get it basically. So
Yeah.
okay, so if we go to next page, and this really confuses the heck out of me.
Yeah. Now he's generalizing this.
Analyzing, but now if it takes morphism between 1 to n when n is between less than 3, then he's listing elements like 2, 1, 2, 3, 3, 3. That confused me. Why is he listing element like 3?
I mean, I get the combinatorics part of what he's doing, but I'm not getting the jump from the equation.
Yeah, that's if you get one, you get the other. But essentially, the problem is first doubt I had is when you're taking the homomorphisms or morphisms here, is he just taking any two elements because it's a finite linear order? Linear order means you'll have any two elements related to each other. Period.
Yeah.
It's not a partial order; it's a linear order.
It
So
can't
in
be.
that
It
case,
has to.
you're very generic. Yeah, sorry.
No, I was just saying it can't be any two because it has to. The morphism has to have to compose, right? So this is also again a combinatorics problem from that point of view.
Okay, so in this case, the first element is bigger than second element. That's how he's morphing basically.
Right.
But why does he have 3 in the first element? Because the source set is 0, 1.
Oh, which one are you looking at now? You're looking at the table?
I'm looking at D. D has an example out there. There it says arrangement of morphisms 1 to n, where n is less than or equal to 3 will help. So he didn't help for me. I don't know if it helps you guys.
Oh, I didn't look at this thing. I didn't look at. Let me see what it's doing here.
So guys, what I said is
So the n plus
put your
one,
thoughts.
n
Yeah,
plus
go
one.
ahead. Go
No,
ahead. Sorry.
no, I was sorry. I was just going to say the n plus one times n plus 2 by 2. That you got right. How you come? How you get that?
No, I can get
Oh,
that also.
okay. So that's also. I mean, on one side you have 0 and 1. Other side you have 0 all the way up to n. So you have to pick two numbers where you should send 0 and where you should send 1. But it has to be non-decreasing. So how many ways are there to do that? That's what he's counting there. So if you take 0 to go to 0, then you can take 1 to go to any of the other ones.
Right. That means for 0 I have n combination. N options available. For
Right.
n I
So you
have
have
n,
options
one.
available.
One I have n operation available. That leads to 2n count basically.
No. So you have n operations there, but then
Okay.
you can also send 0 to 1 here. Then you can send 1 to any of the n minus 1 ones. So you have to basically it's a sum. That's why it's coming to n plus 1 and n plus 2 by 2. It's coming to n plus 1 because if there are n of them, actually there are n plus 1 elements because you are going from 0 to n. So there are n plus 1 objects to which you can send 0. Right. So that's why it's n plus 1 and n plus 2 by 2. That's a sum. That's why it's becoming n plus 1 into n plus 2 by 2.
Okay. I'll have to work to that. I know I hear what you're saying, but I have to ingest it more. So
Oh
go
yeah,
ahead.
that's how the sum is coming.
Okay.
Yeah,
What
so
about his example here?
I didn't look at the actual the example there. Um,
Okay, let's do one thing. At least I only stayed up to this point, and this is where I was stuck. Why don't you guys post your responses to Google group, and we can look at that. I'll also do some generation of some of this through Python code and see if we can get what he's asking. I'm getting some vague suspicion that the morphisms I'm thinking back of my mind are not what he's really putting out there.
okay, yeah. So the generalized one, I took a look at that, and I think it's a basically a general combinatorics problem. What's it called? It's got some stars and something. I forgot the name. Let me try to figure out what it was.
Yeah. I mean, he's essentially trying to walk you through the low case sets for these and then build up to generalizing to the bigger thing.
Yeah, yeah.
Sure.
So I think the key is I even go back in this, part A and do, 0, 0 or 0, 1 and make it, even easier and then work your way up. Um,
Yeah, Chris, the problem is 1 and 2 seems to be relatively simple, and you can sort of enumerate and you get the answer right away. There's no issue in that.
yeah.
3 is one that confused me, and 4 is that. Forget about the count for a moment. I didn't even know what the heck. At the D, I start getting doubts about whether morphism I'm putting are right or not.
Yeah. Or
Uh,
or do some of the cases on the kind of the triangle across here rather than I mean he's doing examples from the two corners I think in a general sense. It may be better to do all these, this, 1, 1, 3 example and then 10.
So I remembered what it was. So I actually tried to figure out how he came to. I looked at the exercise E and
uh-huh.
tried to figure out how this n plus m plus 1 cn comes from. So that is basically one thing that I found which made it easier for me to figure out is this Wikipedia entry which I posted here about stars
Okay.
and stars combinatorics.
Okay. Okay.
So so I went there and I read through this, and this kind of made it easier for me. It's a combinatorics problem
Okay.
basically.
I'll take a look at
The
that.
way to
Thanks
think
for
about the combinatorics is using the stars and bars thing.
Yeah.
that.
He
Okay.
posted it in the group chat there if you're not looking at the group chat,
I got the link.
which I'm not half the time.
But that doesn't have anything to do with actually category theory per se. I mean, what we are it's basically about how to do a combinatorics thing of choosing these
Okay.
the numbers.
See, one question, I mean, not question, one for pre-orders and partial orders, his morphisms are less than or equal to. I mean, less than or equal to symbol, you can't just take that as morphism. But in a pre-order, you really can take less than or equal to, like, x is less than or equal to 5 means 3 is less than or equal to 4, you can do those sort of things. Then the question came, is the morphism same when you go to linear orders? So, is it simply a partial order like less than or equal to, or is it something more than that? So I guess that's where I'm a little confused. But let me do one thing. Let me work out on this thing, bang on it for some time, and I'll get back to you guys with what results I get. And
Yeah.
at least from my side, this is a distance I could go so far. If you guys gone further, you can continue. But I want to sort of sign off right now. And, I would like to move on. Call it a
Yeah,
day. Okay?
where did the time go?
Huh?
Where did the time go?
I don't know.
Oh, the time always flies when you have fun.
Yeah.
Well, I think I know too the issue that you're having, Ram. And let me think for a while, and I'll see if I can come up with an example.
That's wonderful. I think
Slightly
all of
different,
you are there.
same thing.
Yeah, yeah. You guys can take a look at that. Let me know what you think.
Yeah. So if you can post
What
like,
rank or test.
if
Give
you
me a
can have a
small
post or
example.
something. Sorry.
I'm sure if you solve one small example, everything falls through very quickly.
Yeah. The other thing I find too doing this is, getting out your pencil and paper and drawing lots of maps by hand
Yeah.
for the low order cases. It gets crazy and you can't do it for the higher order cases, or it becomes
Correct.
very tedious.
Yeah.
So on C, maybe you can let me know if I'm getting this right. So each column represents where you map 0. The first column represents where you map 0 to.
Yeah, that's what.
The second column represents where you map 1 to, and the third column represents where you map 2 to, right?
That's correct.
So
Yeah.
0, 0, 0 means 0 gets mapped to 0, 1 gets mapped to 0, and 2 gets mapped to 0.
Right.
0, 0, 1 is where 2 gets mapped to 1. Is that right?
Yeah.
Okay, so that's where okay. I didn't actually look at the picture very much.
No, I would like to reread that section again because I was confused on that listing also. Said this. He says, if you look at what he's saying, this can be, you can get it by writing all the non-decreasing sequence of the line numbers. It's same as writing non-sequence. I don't know what he means by same as. It could be what you say. You're mapping 0, 0, 0 is 0, 0, 1, or is it? He's got some isomorphism that says no, this is a sequence maps correctly to that. I don't know. I still had to work that out.
Well, I think the tough part here too is I get the impression he's way more of a computer scientist and has spent a lot more time in combinatorics.
Correct. Exactly.
He's making the jump from the maps to the, when he says it's the same thing as writing a non-decreasing sequence of 3 numbers, that's a jump that combinatoricists would just kind of throw out there and say, here it is. But he's missing 2 steps of writing out all the maps to show why that's actually the case. And I think that's the problem you're having.
So it has to be non-decreasing because of the linear order, right? Because if you had a decreasing sequence, then, for instance, if you had 2, 1, 0, then whenever you take the morphism, you would have that f of 0 is actually bigger, or it isn't actually less than or equal, it's not ordered with f of 1. So if it's decreasing, so if it's decreasing, the morphism, the order isn't preserved across the morphism. Maybe that helps. So that's why it's non-decreasing, because if it was decreasing, the order would not work. And so basically any non-decreasing sequence will work because you don't need, you only need that the order being preserved, right? So it doesn't really matter, right?
Okay, and I think you made an interesting observation that what he's writing out there is in the domain I have number 0, 1, 2.
Right.
In the range I have three digits. So
the domain is 3 digits, right? And then the codomain is 4.
Yeah.
Codomain is 4.
Yeah.
And so each one has one less degree of freedom. So once you've chosen, a set, you can
Yeah, and you don't have to map. Oh man. Someone's Yeah, so you don't actually have to map all the elements of the domain to the codomain. Like, it doesn't have to be surjective. So you can just map everything to 0, which is what the first row is saying. I'll be quiet.
I'm not sure who it is, but it's happening to all of them. me see if we can mute and make it stop. Maybe
Oh.
it was a run.
Yeah,
Yeah.
apparently.
Somebody's got their speakers in front of their microphone. And I think it may be a run that's having that issue. So
I'm using the inbuilt speaker, so maybe it's me. I don't know. I'm using the inbuilt one.
So guys, I need to sign off right now, and I'll see you guys later. Okay?
Oh,
Alrighty.
before you go, Rama, here's the big question for next week. How far should we go through for next week?
It's up to you guys. I don't know how much you know. We can go up to 5.2, and that way you get a good, deep understanding of what's happening this week.
Yeah, I mean,
quite a bit of 5.1 still remaining.
I didn't
So
actually
I would
get through
say-
all of 5.2.
You didn't? Okay. Well, so let's for next week. Let's get to the end of 5.2 for next Monday.
Okay.
Although start
Okay.
reading through 5.3 if you get a chance.
Yeah, I have a couple of questions about 5.2 as well. So.
Okay. All right. Well, we'll do that then next week, and I'll modify the syllabus. But since we're the core group moving forward, we may as well match our own pace rather than some external pie in the sky goal. I mean, I'd like to finish before the end of the summer, but I had a feeling this was going to happen about halfway through. So
Hey,
Yeah.
you're better than Georgie group. We did one chapter for 3 months. Okay.
Oh, wow.
yeah. Are you into chapter 2 yet? Even?
Huh?
Are you into chapter 2 yet in that book?
Yeah. Yes. We got into chapter 2 after a lot of battles on finite groups.
Jeez.
And finally, I think we got some understanding of finite groups, but 2 is relatively easy. It's all Lie groups, so it's much easier. Lie algebra.
Yeah.
Something we know.
Well, let me know when you
All
run
right,
into
guys, good night.
it.
I'll see you guys later. Okay.
All right. Bye, Rama.
See ya.
Bye. See you guys next week.
I'll probably to be leaving here in a second. So this was, yeah, I actually had my comprehensive exam on Thursday, so I've been a little busy.
Oh, for crying out loud.
Yeah, and I just got back from that week-long whatever computational neuroscience thing, which turned out not to have a lot to do with computational neuroscience.
Oh, it didn't?
It was mostly statistics. I mean, it was kind of some methods people used in the area, but it wasn't really anything like, so they were unrelated topics, but just happened to be applicable, but no one applied them, right? Except maybe one person.
Wow.
Yeah.
That's entertaining.
Yeah, and the guy, the guy who like organized the whole thing, at the end of it, so he basically just said, you know, all the things that people have been doing are all right and everything, but let me show you what I've been doing and how it's this much better and everything. And it's kind of a, I don't know, silly move. It was amusing though.
Well, did you learn anything?
Mildly, I learned more about job prospects than actually like math.
Oh, yeah. That's always good.
Yeah. Oh yeah, and that one problem I was having with my program that I mentioned a long time ago, like a couple weeks ago, where it was randomly getting negative numbers. And I said it wasn't an overflow error, and it was. And I'm upset.
Yeah.
I had changed everything to a long, except one object, or one integer value. And I didn't notice. So, woo.
Oh.
Yeah.
Painful.
Anyway.
All right. Well, that's all I got. We'll let you get back to work, and we'll try and get through the end of next Monday's section. We'll get through the end of 5.2, and possibly get into 5.3 if everybody has some time to start reading the next section.
All
Now
right.
that I'm back from traveling myself, I'll maybe actually make a post to that effect. So 4 other people I know who are kind of following or lurking along in the background can play some catch up and stay up with us. So, all right.
Okay.
Alrighty.
Have a good one, Arun. Night, Daniel.
Thanks, you too. Thanks, you guys.
Bye.
Bye.